All right, this video is going to be about how you actually build AI systems that are super useful and are probably going to be how the future of, the death of the white collar worker actually happens. And it's going to be through stuff like this. So if you remember a while back, I made a video on how to make AI systems feel like AGI. And the whole point of that video was you had to have a single voice agent that speaks to the human. And then behind that, disguised behind that one voice of that agent, there are many different channels and routes of you can think like a sub-employee architecture structure for that agent to actually go and operate. So it's not one AI agent that has access to maybe 5 different tools. Instead, it's one AI agent that has access to 15 different AI agents who are all specialized to do certain tasks. And now we're going to go even a bit further down and kind of discuss, well, what happened? How do we actually make those 15 other AI agents accurately make decisions and analyze different stuff in the business so that that one executive voice agent that the human is talking to is super useful? And it comes through this. So recently I built a system where from just spoken conversation, it would output a fully 180, between 150 and 180 line item task schedule for a new residential construction build. And essentially what that system did was the LLMs that I used in there, instead of actually having them create the tasks for the schedule, I instead had the LLM parse the voice inputs from the contractor and turn those into variables to plug into an algorithm or an equation that then made the decision on the business's behalf. So I'm starting to shift my way of building these systems from good prompting to good algorithm designing around the problems of the business themselves. So right now, the point in the AI revolution of where we are is people like me are building these systems that are coming for office workers' jobs. If you do any type of intelligent reasoning or decision making, these are the systems that we're first going to build to kind of, in a way, analyze all of the inputs and already have algorithms to essentially give you a list of 5 to 10 what if scenarios that are accurately scored with probabilities. So this example I have here is the game engine that I'm building for Opulence, our software as a service. And you'll see here each of these 6 different categories in purple are different aspects of a general contractor's mental burden that they have to think through. So scheduling and sequencing in a traditional Gantt chart or Microsoft Excel. You have a resource and crew management, weather and environmental impact and issues, materials and procurement, financial bidding and intelligence, and then site safety and quality metrics. So there's going to be more stuff than just these ones I've listed, but these are kind of the way that I could group out the 6 different mental thinking burden that a good contractor goes through. And now in black, in all of these are different algorithms or equations that I'm essentially going to build and design to hand over to an AI agent or an AI cluster to use as tools. So all of these you can really look as they're going to be tools for AI agents, because I don't trust, at least where the AIs are right now, and usually maybe even the future after it already gets general intelligence. I want their recommendations for business decisions that need to be made. They need to come from math. Math is a way of modeling reality. Math is a way of modeling reality, and as we humans do, we like to predict things. So AI is an extension of our thinking power, and right now it's too stupid and to just based on the already ingrained math it has going on its head. It's too stupid to make reliable decisions, in my humble opinion. So instead, I'd rather utilize the true power of this technology, which is understanding and making meaning from messy, uncategorized voice input or words or any type of data, and then translating that to being the Rosetta Stone for variables to plug into each one of these algorithms, and then based on the outputs of those algorithms, offering up or re-showing that now calculated information back to the human in the loop so the human can make the decision. So you can imagine, let's go for an example. So let's say for the weather and environmental impact part of the game engine, weather delay probability. So this algorithm would be, okay, looking at our schedule, what tasks are done this week, the weather, is it raining this week, is it whatever? What is the probability that we're going to get a weather delay, and which tasks are on more of a high lookout than others? So the AI would run that either automatically or on the request from the user, speaking through it via voice, and the agent would then go and activate this part of its brain or this part of its cluster. It would then run this. It would put in all of the data inputs that it needs. And then this would output something like, I don't know, 0.81. So like that'd be 81% chance. And then we can basically say if anything's higher than 77% chance, then you need to indicate to the contractor which tasks are going to be affected, and like the probability of that based on the weather. And then what gets really cool is, okay, so now that we have this information, like, oh my gosh, my concrete pour is going to be affected by this weather. Okay, so that means as a contractor, traditionally, you would just have to kind of sit there and, look at your Excel and kind of exist in your own thoughts and think of all the possibilities. But now you can have a conversation with your schedule, with your buddy, and you can basically go and send this over to the scheduling and sequencing engine. Or actually, no, you would actually send it to here. I forgot it. I wrote an algorithm in this bucket. So then the agent would then send it and say, okay, hey, weather task rescheduler, how do I reschedule my schedule and not screw up everything? I don't want to push out the critical deadline. I want to have minimal damage to my schedule and not affect any of the subcontractors or the other work. How can I do that? And this is another algorithm. It's another equation where I have to figure out the inputs of it, and basically the AI will recommend 3 to 4 to 5 different options that the contractor can do. And then the contractor just engages in this dialogue where it's like, I really like that idea, but I'm thinking based on my experience that maybe we should go this direction. So maybe he can modify these certain plans that are given. It can just say, I like that one, go commit it to the schedule. And if he says go commit it to the schedule, then he can go and send it over yonder to the schedule, not the schedule builder, to the, to over here. Like over here, this would be the part of the brain that actually commits changes to the schedule. So, yeah. So your goal as an AI engineer, if you're building a thinking executive agent buddy for some type of niche or business, your job is to become an algorithm builder. Part of your human intelligence is best utilized with taking reality, taking all of the potential variables that could affect a decision or an outcome in a business, and translating that into an equation or an algorithm that, based on the output of that equation, would signal what the best decision is to do, or maybe not the best, but what is the better alternatives. And this is the core of what I call algorithmic AI building, or algorithmic agent building, where the agents are not the ones making the decision. The agents are the one essentially doing the research and using their algorithms as tools to go and then present all of their research and their good hard work to the CEO, which now is all of us humans. And it's very much the same thing that happens in the working world, right? Like you go send your market analysis people, you go get consulting, and they do a lot of this work. And those consultants, they don't have necessarily equations in their head, but they're doing physical, mental labor in the world that can be modeled by some type of math equation. You just need to know the inputs and you need to know what they're doing in their head, like what are they actually thinking about, reasoning about, and then you need to turn that into a algorithm. And AI is really good. ChatGPT is really good with helping with that. So if you say, I'm not good with math, I don't want to hear it because I'm not either, but I still make it work. Yeah, that's kind of going to be all. I'm going to start tackling these one by one. We already have a lot of the schedule builder built, but there's a lot more to build. There's 40 different algorithms here I need to build. So I'm going to be in my lab building. Comment if you have any questions or thoughts. And yeah, keep on keeping on.